We have learned how to solve linear systems by graphing or algebraically by doing substitution or elimination. And today we are going to apply this knowledge to word problems. So whenever you read a word problem, you really want to ask yourself, what is the question asking me for? Because whatever you're being asked to find, that's usually going to be the let statement. And because we have a linear system and we have two different variables here, and we're going to create two equations, we're going to need two let statements, one for each variable. Then once you've created your let statements, you want to look at the key information, and there's usually two key sentences, and those sentences will give you the two equations you need. And then from there, you can solve using substitution or elimination. And then make sure at the end you write your therefore statement. Now, most scenarios you're going to solve algebraically. There is one scenario where maybe you want to solve by graphing, and that's a better deals scenario. And you don't have to graph, you can still solve algebraically and just use a visual later on. So let's read the first scenario. Good Life charges $50 per month for a gym membership. LA Fitness charges $40 per month plus a $100 sign-up fee. Determine when the cost of both memberships is the same. So it is asking me for the point of intersection. Now, if you want, you can graph this and create a table of values like you did in grade 9, graph the two lines, and then see the point of intersection. I'm going to solve this using substitution and use the graph as a visual for part B. So whenever you have a better deal scenario, one of your variables is going to be cost, because we're dealing with the better deal for cost, and the other one will be what cost depends on, which in this case is the number of months you attend. So for my let statements, I'm going to say let X represent number of months, let Y represent cost. And you could have used M and C, whatever you want. So I'm going to do one formula for Good Life. So my cost is equal to $50 per month. So if X is the number of months, I'm going to multiply 50 by X, and that will give me the monthly overall charge. So if I had 10 months, 50 times 10. And that's it for Good Life because they don't have a sign-up fee. But for LA Fitness, the cost is $40 per month, so 40x, but then you have to add on this one-time sign-up fee. So the 40 and the 50, the per month charge, that's your slope, it's the rate of change. And then the sign-up fee, which is a one-time thing, that would be your y-intercept. So a better deal scenario will always give you the equation in y equals mx plus b, because y is always going to be your cost. So now I want to solve this system. And you can use substitution or elimination here, it's up to you. I personally would want to do substitution because I already have my y's isolated for, so I can just set them equal to each other. So all I'm going to do is write 50x is equal to 40x plus 100. And all I did there was, in the first equation, y is equal to 50x. So I went to my second equation, and where I saw y, I replaced it with 50x because they're equivalent. And now, once I did that substitution, I don't have any more y's I have to worry about, and I can just isolate for x, which means I'm going to bring the 40x over so that I have 50x minus 40x equals 100. That's 10 x's, and then I can divide both sides by 10. So x equals 10. And if I go back to my let statement, I see that x represents the number of months. So for 10 months, the price will be the same. And if I want to find that cost, I will take this 10 and sub it into either equation. I'm going to sub it into the Good Life equation because it is easier just to do 50 times 10. And that's $500 for 10 months. And I can also check my work by taking this 50 and plugging it into the LA Fitness one as well to make sure I do get 500. So I'll do that in my head. 40 times 10 is 400, and when I add on the 100, I get $50. So this is perfect. This is correct. Therefore, for 10 months, both cost $500. And now, For part B, it says, under which conditions is each membership better? For this one, I like the visual. So I'm just gonna go to my graph and I'm gonna plot my point of intersection. So 10 months is $500. So over here. And then I'm gonna very roughly sketch my other two lines. And all I'm gonna use is the y-intercepts. So for Good Life, there's no initial fee. So 0 months costs $0. So this is the Good Life line. And I only need 2 points to draw a line. And because I already have the point of intersection and I have the y-intercept, that's all I need. And for LA Fitness, the initial cost is $100, but it also passes through that point of intersection. So there's the LA Fitness line. Now visually, I can see when each line is better. So when it's less than 10 months, Good Life is better. But then once you go more than 10 months, LA Fitness is better. So those are the criteria you need to state. For 10 months, the cost is the same, which we already said in part A. But now, less than 10 months, choose Good Life. More than 10 months, choose LA Fitness. And there you go, that's your better deals. And really only the better deals scenario will be in this y equals mx plus b. And it's only these scenarios where you might want a visual or graph to visualize that better deals conditions, like when is one scenario better than the other. Now, let's go to some other applications, and these ones will not be y equals mx plus b. They will be more in a standard form. So let's try some out. Chandler and Joey are playing basketball. Joey scored one more than double Chandler's points. Together, they scored 22 points. How many points did they each score? So first thing, let's read the final sentence with the question to figure out our let statements. How many points did they each score? That means one variable should be the number of points Joey scored and the other how many Chandler scored. So let X represent Joey's points. Let Y represent Chandler's points. Now there should be two sentences in here that give us our two statements. Here's the first one. Joey, which is X, scored more than double Chandler's points. And then the second one, together, they scored 22 points. So let's take that first statement. Joey, which is X, scored one more than double Chandler's points. So Joey's points are equal to one more, which means adding one, to double Chandler's points. And double means multiplying by 2. So 2y would be double Chandler's points, but we want to be one more than that. So there's our first equation. Now the second one. Together, they scored 22 points. So if I add Joey's points and Chandler's points, they should add up to 22. So x plus y equals 22. And there's your linear system. Now you solve. Substitution or elimination, the choice is yours. But in this scenario, because my variables are not lined up, like the x's, y's, and constants, and the equal signs, I'm not going to do elimination. I already have a variable that is isolated for. I already know x is equal to 2y plus 1. So in the second equation, I'll replace x with that expression and then go from there. So I am going to do substitution once again. So 2y plus 1, so that's the x part, plus y equals 22. Now I'm just going to isolate for y. So I'll bring the 1 over, and it will become minus 1. Now I'll collect my like terms, and then I can divide out that 3. So I get y equals 7. And if I go to my let statements, I see y is Chandler's points. And if I want Joey's points, I'm going to sub it into either equation, but I'm going to sub it into the first one because it looks easier. So 2y, so 2 times 7 plus 1. That's 14 plus 1, which is 15 points for Joey. And then I can check my work in the second equation. x plus y. So 15 plus 7 should equal 22, which it does, so I'm happy. And now I can write my therefore statement. Therefore, Joey scored 15 points and Chandler scored 7. And that's just a general application. And let's try another one. And in this one, we're just going to set up our scenario. I'm not going to bother solving it because really the new skill here is setting up the linear system. So a garden is to be fenced off with 18 meters of fencing. The length is 1 less than triple the width. Determine the dimensions of the garden. Determine the dimensions of the garden tells us what our let statements should be. The dimensions. So I have a length and a width. So I will say, let x represent length, let y represent width. Now let's reread for our two statements. A garden is to be fenced off with 18 meters of fencing. That's the perimeter. So if I add up my two lengths and my two widths, that should give me 18 meters. So 2 x's and 2 y's will be 18. And we can draw a little sketch here if we wanted to. Here's what my garden looks like, and all 4 of those sides should add up to 18. So there's my first equation. The next one, the length is 1 less than triple the width, similar to that Chandler scenario. So my length is x, and it's going to be 1 less, which means I'm subtracting 1 from triple the width, and triple the width will be 3y. And there it is. And now you can do whatever you want, substitution or elimination. I would personally do substitution because I already have a variable isolated for, but you could also do elimination if you took this 3y and brought it to the other side so that everything lines up. Now, let's try our next one. After playing her guitar outside Central Park, Phoebe has a collection of quarters and dimes. If she has 32 coins in total, worth $6.35, determine how many of each coin she has earned. So here it is. There's my question. I want to know the number of quarters and the number of dimes. So there's my let statements. Let x represent number of quarters. Let y represent number of dimes. And make sure you're not just writing let x represent quarters, let y represent dimes, because x is not a quarter. X represents the number. So make sure you're specific. Now let's reread some sentences. It says that she has 32 coins in total. So if I took the number of quarters and the number of dimes and I added it, that should give me 32. So there's my first equation. X plus y is 32. Now the rest of it says that they are worth $6.35. Now we need to remember, quarters are worth 25 cents, which can be written as $0.25, and dimes are worth 10 cents, which can be written as $0.10. So now, this next statement is about the total worth. So if I have x quarters, the value of those quarters will be 0.25 times x. So for example, if I had 4 quarters, I would do 4 times 0.25. That gives me $1 worth of quarters. But I'm going to do this with my variables instead. So 0.25x represents the number of the value of the quarters, and then I'll do the same thing for the dimes. 0.10 times y quarters. So that will give me the value of the dimes. And if I add that together, I should get $6.35. And there we go. Now we can solve using substitution or elimination. The choice is yours. I'm going to do elimination here because I haven't done it yet, and I see that both equations are in standard form. So I'm choosing to eliminate the x's. So if I want to eliminate my x's, I need the coefficients to match. So I am going to multiply this first equation by 0.25. So then I get 0.25x plus 0.25y equals, and now I'll do 32 times 0.25, which is 8. Now, to get rid of the x's, they're both positive, so if I subtract my lines, I will get 0 x's. And now I have to do it for everything else. So 0.10y minus 0.25y is negative 0.15y. And then 6.35 minus 8 is negative 1.65. Now, we've gotten rid of the x's. We can just divide both sides by negative 0.15. And we get y equals 11. And now we know that y is dimes, so we have 11 dimes. And now I can sub it into either equation to figure out the number of quarters. So I'm going to sub it into that top one. So x plus 11 for y equals 32. I'll bring the 11 over, and 32 minus 11, and I get 21 of the quarters. And then I can just check the second statement and know that quarters are worth 25 cents, dimes are worth 10, so 21 times 0.25 plus 11 times 0.10 to make sure it gives me 635. And then, therefore, Phoebe has 21 quarters and 11 dimes. And there we go. So these money ones with coins, that's a common one. You saw something similar in grade 9 as well, but you never solved it as a linear system because you didn't do that skill in grade 9. So now let's move on. A landscaping company placed 2 orders with a nursery. The first order was for 13 shrubs and 4 trees and totaled $487, and the second order was for 3 shrubs and 1 tree and totaled $116. What were the costs of 1 shrub and of 1 tree? So let's read that final statement or question. What were the costs of 1 shrub and 1 tree? There are my let statements. I need to know the cost of a shrub, so let x represent cost of shrub. And I need to know the cost of a tree, so let y represent cost of tree. And now let's reread. We have 2 sentences here, but the first order and the second order. The first order, 13 shrubs and 4 trees, was $487. So if I had 13 shrubs and each shrub cost X dollars, that would be 13X, because if I had 2 shrubs, I would do 13 times 2 is 26. And then I have 4 trees. So 4 times y would be the cost of all the trees. And if we add those 2 costs together, we'll get 487. Let's try the second order. 3 shrubs and 1 tree was $116. So 3 shrubs plus 1 tree, 116. And then here, this is a perfect system for elimination because again, x's, y's, and constants are lined up perfectly. But you could also do substitution because you can easily isolate for the y and then sub it into the first equation. The choice is yours. So I want you to pause the video here and solve this. And when you come back, I'll have the full solution set up already. So please pause and try to finish this off on your own. All right, so here's what we have. I did elimination and tried to get rid of my y's. So I multiplied my second line by 4. I subtracted the lines and got the cost of a shrub right away, which I then subbed in. Now, when you're solving this, there are some clues that will tell you that you really messed up. And if you get a negative cost for one of your variables, you know that doesn't make sense. So go back, maybe you set up your equation incorrectly, or you solved it incorrectly, made a silly mistake with the signs or something like that. So make sure you do a logic check at the end and just do a logic check with the scenario. Make sure that 13 shrubs and 4 trees actually cost $487 and that 3 shrubs and 1 tree actually costs $116. And you can do that quickly in your calculator. All right, we have one more example that I want us to try out. So when you rent a car, you are charged a daily fee plus a cost per kilometer. When Sana rented a car for 3 days and drove 160 kilometers, the charge was $124. When she rented the same car for 5 days and drove 400 kilometers, the charge was 240. What was the charge per day and the charge per kilometer? So we should already know what our let statements are. So I want you to pause the video here, write down your let statements, because we can see that one of them is going to be the charge per day and the other will be the charge per kilometer, and then try to find those two sentences to set up your linear system. We're not going to solve this one, we're just going to set it up. So please pause here and try to see how you do it so that you can learn from your mistakes if you do make a mistake. All right, so hopefully for your let statements, let X represent charge per day, let Y represent charge per kilometer. And now our two sentences are about each day. 3 days and 160 kilometers was $124. So 3 days would be 3x, 160 kilometers would be 160y, and that's $124 in total. So hopefully that was your first equation. Then we have 5 days and 400 kilometers was 240. So 5 days would be 5 times x for the total daily charges. And we have 400 kilometers, so 400 times the charge per kilometer. And in total, that will be 240. And then here, if you were to solve this, I would definitely do elimination. And there you go. That's how you set up your linear systems for some general scenarios. And most of these are about a bit about cost or the dimensions of shapes or points, very general examples. And just to reiterate, the final statement about your question and what you're being asked to find, those are your let statements. And then just go in and look for two sentences to give you your two equations. And then from there, it's a skill you already have. Do substitution or do elimination.